Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we're going to talk about GMAT probability, and in this video we will learn how do you really master the skill of probability. Well, the overall idea is to keep everything as simple as possible. It's not as easy as it sounds, but with practice it can get very easy. So let's just get started. So I'm just gonna flip the classroom here. I've just picked up some GMAT related questions. We'll start off with some easy probability questions, and then we'll move on to some difficult ones, and then we'll see what skills we learn while solving these questions. So feel free to pause the video and try out the questions by yourself, and then you can watch my solution for it. So we're gonna start off with an easy question here. So the question here is that if the probability of rain on any given day is half, by the way, that's something that I always do in probabilities, is that I don't deal with percentages. I think that confuses you. I deal with fractions here, but whatever you like doing it. So the probability of raining is 1/2, and what is the probability that it rains exactly 3 days in a 5-day period? So one of the first things that I do in probability questions is that I create a higher order problem. So I kind of, kind of take out the content from the question and kind of simplify the question. So the first thing that I'm going to do is that I want to know what it exactly is asking. So it's saying that it's a 5-day period. So that means there are 1, 2, 3, 4, 5 slots. You can say that. You can call it there are 5 slots. And you're supposed to fill up these slots. And that's all probability questions are all about when it comes to GMAT. It's all about filling up slots. And it says in 5 slots, it has to rain exactly 3 days out of 5 days. So basically, to declutter this question, you can say this question is asking me is that how many times will it rain? So I'm just going to use a letter for that. That's what I'll use all the time. Rain and rain. So basically all rainy days are the same. There's no difference between rainy days. And then no rain and no rain. So this is exactly what the question is asking me. The question is asking me how many days it's going to rain exactly 3 days, and what's the probability of that. And of course, when it rains exactly 3 days, that means it doesn't rain the next 2 days. And the question is asking me the variations of it, right? Because right now it's raining for the first 3 days and it's not raining for the next 2 days, but it can change a lot. It can rain for the first day, not rain for the second day, and the rain for the next 2 days, and so on. So if I can get the probability of this and then multiply this probability with the number of times this word sequence can arrange itself, then I have my answer, right? So this is what I call the slot method. I have detailed videos on teaching the slot method, but this is kind of the nutshell of it, is that you kind of declutter the question. First identify how many slots it's asking you to fill it up, and then you bring it down to simple words, and then you find how many arrangements is it asking you to solve. So basically it's asking us it has to rain 3 times and not rain 2 times, and since the number of rainy days are all the rainy days are all similar, and not rainy days are also similar, so they can arrange themselves in so many ways. So how do we solve this question? So first of all, we can just get started with this letter format here. So what's the probability of raining? It's 1/2, right? And what's the probability of another day raining? It's 1/2 again. What's the probability of another day raining? It's 1/2 again. Then what's the probability of not raining? Of course, if the probability of raining is 1/2, then the probability of not raining is 1 minus 1/2, right? Because that's how probabilities work. The probability of something happening is x, then probability of something that not happening is 1 minus x, because all probabilities sum to 1. So the probability of not raining is actually 1/2. So I kind of put these probabilities here. So probability here and probability here. Now I'm writing this all for you because I want you to understand. I would just typically write 1 by 2 raised to the power 5. So I'll just I can just write this whole thing as this, right? So I can just write the whole thing as this. Let's talk about the second part of this. The second part of this is, in how many ways can this n can arrange itself, right? Because it says it has to rain exactly 3 days, but it doesn't specify which 3 days. So it can rain on any 3 days. Now this part of the solution is very simple. So what you do is you just count how many slots are there. So you got 1, 2, 3, 4, 5. So you say 5 factorial divided by the number of combinations that are there. So basically there are 3 R's and 2 N's, and those are being over counted when I do say 5 factorial. Again, I have a detailed video on this specific arrangement, but I'm just going to give you the solution here. So you say 5 factorial divided by 3 factorial times 2 factorial. Now why do I do that? Because when I say 5 factorial, I'm basically assuming all R's are different and all N's are different. So I overcount. To reduce that overcounting, I have to divide by the number of groups which are available in this particular string of letters. So there are 3 R's and 2 N's. So hence I divide by 3 factorial and I divide by 2 factorial. Now if I start calculating this, so it's going to be pretty simple. So 3 and 5 factorial will just give you 4 times 5. Then this is just going to give you a 2. And then this 2 takes away this 2. And I am actually left with 5 divided by 16. Why 16? Because I'm left with 4 2's here. So my answer is 5 by 16. So let me just give you an overview of what I just did here. The step 1 in any probability question is to declutter the question. Take out the context, because all probability questions in GMAT are very similar. So take out the context. Try to find out what is it asking you. So usually it will ask you to fill up slots. So you got 5 slots. You got to fill up 5-day periods. Then fill up one variation of that 5 slot. So he wants you to rain 3 times and not rain 2 times. So you got R, and N. Then once you have that one variation of that, then try to find how many times you can arrange it. So you multiply the probabilities of independent events by the times they can be arranged, and then you actually get the answer. Just for your information, I have very detailed videos about each whatever I'm saying here. Each video is probably 40 minutes long, explaining everything about why am I arranging, why am I multiplying. I mean, I'm talking about the mathematical background of everything. Okay, so the answer is 5 by 16. That was an easy question, I'll give you that, right? So let's move on to the next one. So we're gonna do another easy question, and I want you to pause the video and try it out yourself, and try to do it in the style I actually just showed it to you. Okay, so the question says, if a certain coin is flipped, the probability that it lands on heads is 1/2. If the coin is flipped 5 times, what is the probability that it land heads up on the first 3 flips and not on the last 2 flips? So if I declutter the question again, it's giving me 5 slots. So 1, 2, 3, 4, 5, because you're flipping the coin 5 times. And it wants you to have heads on the first 3 slots. And it wants you to have tails, if you want to have heads on the first 3 flips, then definitely that it wants tails on the next 2 flips, right? Because that's what it wants. It wants exactly that. It says, what is the probability that it will land up heads up on the first 3 and not on the last 2? And here's a question I'm going to ask you, and you have to think about it. What do you think is the arrangement of this particular scenario? Can you arrange this further? Well, the answer is not. This is the only arrangement that you get, because the question has clearly specified that it wants the first 3 flips to be heads. If the question was, what is the probability of getting 3 heads and 2 tails, then you could have arranged it in so many different ways. But here, it has specifically given you the arrangement. So that means there's only one way you can arrange this scenario, that it has to be first 3 heads and last 2 tails. And the question becomes pretty simple. What's the probability of head? 1/2. What is the probability of another head? one half. What is the probability of another head? One half, tails is one half, and tails is one half. If you multiply all the one halves, you actually get 1 by 32. So that is the answer. So I hope this is helping you guys out, and if you have any questions, you can let me know in comments. So I'm gonna move on to the next question. Again, that's also gonna be an easy question, but a little different question than this. Okay, so here's another question which we will try to solve using our method here. So the question says that the probability, by the way, the reason I'm using different types of questions is because I want to give you the whole variety of different types of questions that can come in GMAT. If you really want to learn about this specific technique, I have detailed videos where I give you 4 or 5 questions of the same type so that you can actually understand. Okay, so the probability is 1/2 that a coin will turn up heads, again, same type. If the coin is tossed 3 times, what is the probability that on at least one of the tosses, the coin will turn up tails? Now, as soon as you see this word at least one, there's something that should trigger inside you to kind of flip this question. Now, what do I mean by flip this question? So I'm just going to give you a general overview. The probability that something will happen at least one time, so the probability that something will happen at least one time is actually 1 minus the probability that something will never happen. So probability that nothing will happen, or probability of none of them happening. I mean, that's the universal probability rule, right? Because at least one means it has to happen at least one time. And if sum of all probabilities is 1, then probability of at least one happening is actually 1 minus the probability of nothing happening. And why this is useful is that because if I say I've tossed a coin 100 times, what is the probability of getting at least one head? Then you start getting into trying to find the probability of 1 head, 2 heads, 3 heads, 4 heads, 5 heads, all the way down till 100 heads. And that's a cumbersome problem to solve. But you can actually flip it. You can say, what is the probability of getting at least one head? That's actually 1 minus probability of getting no heads, which is a much simpler problem to solve. So whenever you see this at least one, this should trigger all the time. So the question is if the coin is tossed 3 times, so that means so the first thing that I'm going to look for is the slots. So if the coin is tossed 3 times, so I have 3 slots. What is the probability that on at least one of the coins you will have a tails, which means I'm asking you 1 minus not getting any tails, which means 1 minus getting all heads, right? Now again, I'm gonna ask you this this question here. Is there any arrangement to these 3 heads? There is no arrangement because you can't arrange HHH more than once. It can only be arranged 1 times, right? It will actually translate to 3 factorial by 3 factorial, which will actually just be 1, right? So you can't really, there's no arrangement to it. So the answer is going to be 1 minus, what is the probability of getting head is 1 by 2. What is the probability of getting another head is 1 by 2. What is the probability of getting another head is 1 by 2. So 1 by 2 times 1 by 2 times 1 by 2 is 1 by 8. So basically it translates to this 1 by 2 times 1 by 2 times 1 by 2. So if you actually solve this, that actually gives you 1 minus 1 by 8. And that actually gives you 7 by 8, which is the answer here, which is answer option D. Okay, so I hope you're getting the hang of it. Now, moving on, let's just notch it up a little bit. Let's go to some medium level questions here, right? Okay, so let's get to this question. So the question says that a coin is tossed 4 times. What is the probability of getting at least 2 tails? So again, the number of slots here. Again, you can pause this video if you like to solve it for yourself. A coin is tossed 4 times. So you got 4 slots, 1, 2, 3, 4, Now, before really getting into numbers, let's see what it's telling us. It says, what is the probability of getting at least 2 tails? So what are the ways you can get 2 tails? You can get 2 tails, or you can get when you get 2 tails, which means you get 2 heads. And the question says at least 2 tails, right? So you say, okay, I can get 3 tails, right? So I can get 1 tail, I can get 2 tails, I can get the 3rd tail. and I can get another head. And then you can get 4 tails, right? So 1, 2, 3, and 4. So basically, this is the overall higher order question solving, right? So before we delve into numbers, we have to make sure that we solve the question this way. Don't straight away go into numbers right there. Now, the probability of heads is 1/2 and the probability of tails is 1/2. It says it's a fair coin, so we're gonna assume that. And now it's all about arrangement, right? Because here you've got some arrangement to do, because you can get the first 2 heads in the first 2 slots, or you can get in the middle of the slot. So there's no order to it, right? So you have to accommodate for all types of arrangement. So I'm just going to simplify stuff for you. So what's the probability of tails is 1/2, probability of tails is 1/2, probability of heads is 1/2, probability of heads is 1/2. So basically, if you multiply all the probabilities, you actually get 1/2 times 1/2 times 1/2 times 1/2. So that basically turns out to be 1/16. So I'm just going to write it here, right? So I'm just going to write all the probabilities, and then we'll deal with the ordering, right? And you can see that these questions have nothing to do with probabilities. It's more about arranging stuff, right? So that's the ironic part of it. Now, how many ways you can arrange TTHH? Now forget about heads and tails. How can you arrange TTHH, right? So it's pretty simple. You say 4 factorial, which is the number of words in the string, divided by number of groups. So you got 2 T's and you got 2 H. Similarly, again, how can you arrange TTTH? So that's the number of words, which is 4 factorial divided by 3 factorial, and H is just 1 factorial, so I'm just going to ignore it. And then how many ways you can arrange TTTT? Well, sorry, it's a multiply here. That's just 4 factorial by 4 factorial, and I'm just going to show it to you, but in your scratch paper, you can just write as 1 here. So if I try to solve this here, so I've got, so one way of solving these probability questions is, if the probabilities are similar, just take the 1/16 out. You don't want to deal with multiplications here, right? So you just can take 1/16 out, and you can just deal with these numbers here. So that's just 1. So that's not a problem. That's a 4. That's not a problem. And then this one gives you 3 times 4, and this one gives you 2. So that's a 6. So 6 plus 4 plus 1. So that actually gives you the answer as 11/16. So that's the answer. So basically, the key to the question, what makes this question a little bit more difficult, why this question is classified as medium, not as easy, is because you're supposed to figure this out. That was it, right? Then it was just a matter of doing computations. So you're supposed to figure out, and again, you can say, what is the probability of getting at least 2 tails? Is 1 minus the probability of not getting at least 2 tails. You can go that route either also, but you can also go this way. That's completely up to you. But I kind of reserve that 1 minus technique to at least 1 only, right? So whenever there's at least 2, I kind of, my natural reaction is to go for and just try to solve the question this way. And then you do the higher order higher order question solving. First you draw out the slots. How many slots are there? So there are 4 slots. And then you kind of find out how many ways you can have those slots being prepared. And then we got 3 ways here. And then you deal with the arrangement of those slots, right? Because the question did not specify any particular order. So you got to account for all types of orders. So that actually gives you the question. Again, you see, we're not dealing with any P's and dealing with any C's. In a way, we're actually talking about all those P's and C's here, but we're not really, going into that mathematical notation. We are keeping things very simple, and I believe that helps and goes a long way in the preparation of GMAT test. Okay, moving on. So that was the answer. So let's see this question here again. Now we're not dealing with coins here, we're actually dealing with employees. So let's see this question. It says, a small company employs 3 men and 5 women. If a team of 4 employees is to be randomly selected, which means there are 4 slots. So we got to select 4 people, right? What is the probability that the team will have exactly 2 women, right? So that's what it's asked. So basically the question is asking women, women, men, men, right? So that's what the question is asking us. Now, how can you really arrange? What's the probabilities here? Because the probabilities are a little different than coins. So coins, the probability is always 1/2, but here the probability is going to change. We're going to start off with this particular letter here. So what is the probability of selecting the first woman? So that's 5 women out of 8 people. So that's the probability, right? Then you move on to the next one. So what is the probability of selecting another woman? Of course, you can't select the same woman again. So you're going to have 4 women out of 7 people, right? Because you've already chosen one. What's the probability of selecting the next man? So how many men are there? 3 men. So you can only select 3 men out of remaining 6 people. And what is the probability of selecting another man? So you got 2 men left out of 5 people. So those are the probabilities. Now you gotta deal with the arrangement, right? Because because here 2 women are women, right? Even though they are different women, but for the question, the W's are the same and the M's are the same. So there is this arrangement here. So how can you arrange WWMM? So that's gonna be 4 factorial, which is the number of letters, divided by 2 factorial times 2 factorial, right? So that's there. Now, so that just solves the question here. So all you got to do is you just got to you can say 4 times 2 is 8, 5 goes with 5, and 3 goes with a 2 here, so 6. Then this one gives me a 3 and a 4. This one gives me a 2. So all I'm left with here, and this, of course, this 2 goes away. So I'm left with this 3, and I'm left with this 7. So that's 3 by 7. And that's my answer here. Right, so that's how we solve this question. Again, questions are going to differ a little bit. You can't have all the questions to be the same. But the overall structure of the question remains the same, that you gotta have some number of slots, then you're gonna figure out how to fill up those slots, then you're gonna figure out how to arrange those slots, right? Write down the probabilities, multiply them by the number of arrangements, right? Okay, let's move on to the next one. Okay, so this question here is about dice. So it says 2 dice are tossed once. What the probability of getting an even number at the first die, or a total of 8? Now, as soon as you see a question of this, because there are 2 events here. Now, before that, we were just dealing with a single event, like you're drawing one time, or you're tossing the coins all together. But here you got 2 different events, right? You want to find out the probability of getting an even number or a total of 8. And you can see that sometimes you can get an even number as well as a total of 8. So this becomes a little different, and I have a detailed video on these kind of probabilities as well. So basically you have an event A. I'm just going to give you some background to it, and you have an event B, and sometimes those events coincide with each other. And if you want to find out the probability of event A happening or the event B happening, so let's suppose that's what you're interested in, that's what the question is asking you, that's basically the probability of event A happening plus the probability of event B happening minus the probability of A as well as B happening. Because when you add A and B, you actually so just a second, this is actually and, so that's how I write it, A and B. So because when you add A and B, you actually overcount this. You count this twice because you're adding it in A as well as you're adding it in B. So you got to subtract it once. So what we want to do is, first, let's just split this question. Let's just focus on event A. What is the probability of getting an even number on the first die? Now, if you watch my die videos, you will know how to calculate die probability. So I'm just gonna do it here. So you got 2 dice. What is the probability of getting an even number on a die? So that's probability of, let's suppose, event A. So probability of getting an even number on the first die is that you get an even number on the first die and you get an odd number on the second die, or you get an even number on the first die as well as you get an even number on the second die, right? So what's the probability of getting an even number on a die? So again, we break it down further, right? So let's just focus on this even number. What's the probability of getting an even number on a first die? That's 1/2, right? Then what's the probability of getting an odd number? That's again 1/2. So that turns out to be 1/4. Then what's the probability of getting an even number? That's 1/2. And what's the probability of getting an even number? That's 1/2. So that actually gives you 1/4 plus 1/4, which is actually 1/2. So that's event A. Okay, so that's simple, right? Now, if you really practice your GMAT, you can just solve it in a jiffy and you'll get a 1/2. I have to explain everything to you, which is why it's taking too much scratch paper and a little bit of time. Now, let's talk about event B. So what's event B here? So event B here is, what is the probability of getting a total of 8? So how can you get a total of 8 in a die? So you can either get a 2 or 6, so that gives you an 8. You can get a 3 and 5, that gives you an 8. You can get a 4 and a 2, that gives you an 8. You can get a 5 and a 3, that gives you an 8. Or you can get a 6 and a 2, that gives you an 8. So how many events are there? So you got 1, 2, 3, 4, 5. So you get 5 events out of a total of, so how many events are there in 2 dies? 36, because you can get either 1 to 6 numbers on the first die as well as 1 to 6 numbers on the second die. So that gives you a total combination of 36 numbers. So that's the probability of event B. There's no ordering here because we literally counted the cases by ourselves, right? And you can see that we've already counted for, positioning. We counted for 2, 6, and 6, 2. Like, I like to solve die questions like this, right? So that's the probability of getting event B. Now let's talk about probability of getting event A as well as the probability of getting event B, because you got to subtract that, right? Remember, because if we add just these two numbers, they will overcount. So it has to be an even number and it has to have a total of 8. So we can just focus here. So how many of them have an even number on the first die? So you got this here, 1, you got this here, 2, and you got this here, 3. So there is a total of 3/36 cases where both the events occur. You get even number on the first die and then you get an 8 total. So now the job is simple. You can just use this expression here. You can say, what is the probability of getting A or B? It's the probability of A, which is 1/2, plus the probability of B, which is 5/36, minus the probability of A and B, which is minus 3/36. So that actually is there, which gives you, so if you kind of solve this up, so 5 minus 3 is 2, that's 2/36, and then you can just make this 36 by multiply by 18 on top and denominator. So 18 plus 2, that's actually 20/36. So that is your answer here, 20/36 right here. So the key takeaway from this question was, again, we were doing the same stuff. I'm starting with basics and I'm kind of building up. The key to this question was that first first understand that it's an either or question. So you got to find probability of either of the event occurring. So you say probability of A plus probability of B minus the probability of both occurring. Don't forget that. And if you forget that, there's going to be one of the answer options right here, which will so you will get answer option E if you don't account for that, and that's actually going to be a wrong answer. Then we just build the question step by step and you moved on. I think if you've practiced probability enough, I think this question should take you just about 1 minute to solve. It shouldn't take you that long, and that's a hard level question. Now let's move on to the next one, which is going to be the last, not the last question. This is going to be the second last question. So it says a fair coin is tossed 5 times, and the question is asking you, what is the probability of getting at least 3 heads on consecutive tosses? So you got to get 3 heads, right? At least 3 heads. Now that's what the question is saying, at least 3 heads. So let's do a higher order solving. So you can get either 3 heads, or you can get either 4 heads, or you can get either 5 heads, right? Now I'm going to start with the easiest one. So what's the probability of getting 5 heads? So that's H, 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 H. So what's the probability of a head? It's 1/2. And if you multiply 1/2 5 times, you get 1 by 32. So there's no order to it because you can only arrange H, 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 H one way. So that's 1 by 32. Let's talk about 4 heads. So if you got 4 heads and they have to come together, right? So 4 heads have to come together. So if you kind of list down 4 heads here, 1, 2, 3, 4, and they have to come together, kind of tie them with a string here, where can a tail come? It can either come here, it can either come here. So you got 2 different possibilities. Now we're talking about the arrangement here, right? So you got 2 different positions for tails. So that's gonna be same, 1 by 32, which is the probability of head, 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 tail. So 1 by 2 multiplied by 5 times. But you got 2 arrangements here, right? So you got 2 arrangements. So that actually becomes, 2 by 32. Now let's talk about 3 heads. Now what are different ways you can get 3 heads? So you can get 3 heads. You can just tie them with a string. Now let's see where you can put the remaining 2 tails. So you can put 1 tail here and 1 tail here. So that's good enough. Or if you, so I'm just gonna write 3 heads like this here. So 3 heads. You can put 2 tails here, right? So that's one way, right? Or you can put 2 tails on the right hand side. That's one way. But why am I thinking about 2 tails? Why can't there be 1 more head and still there is just a string of 3 heads? So there can be 3 heads like this and 1 head here and 1 tail, right? So that also gives you a string of 3 heads because you get at least 3 heads on consecutive tosses. That's what you're getting. And that's different from the other possibilities. And you can do it same for the other side, is that you can get 3 heads here and then you can get a tail and you can get a head. So basically there are 1, 2, 3, 1, 2, 3, 4, 5. So there are 5 different cases that you can get. And again, the probability if you multiply of all of these 5 heads and 5 tails is 1 by 32. So you get this. So that basically solves the question, and you add all the probabilities. So you got 5 by 32, and then you got 2 by 32, and then you got 1 by 32. So that's basically 8 by 32. So 8 by 32 is nothing but 1 by 4, and that's exactly the answer here. So I hope you got this question, and this question was, and again, it's a difficult question. However, it's not difficult if you follow the process. You figure out how many slots you got and what are the different arrangements, and do it step by step. You don't have to solve it in one go. Do it step by step, and then keep your scratch paperwork clean. Write it very cleanly so that if you make a mistake, you can figure out where you're making the mistake and what's not coming out, right? So there's that. And trick to the question was figuring this out. I mean, that's what made this question difficult. Like, you can get a head, 3 strings of head with 4 heads as well, right? So that was the trick to figuring it out. So once you figure that out, it's not that difficult. All right, so let's solve last question, right? So, and this is a classic GMAT question. It says that, so Tanya prepared 4 letters sent to be 4 different addresses. And you can pause this question if you want to solve it yourself. And for each letter, she prepared an envelope with its correct address, and they are sent to be put in 4 envelopes at random. What is the probability that only 1 letter will be in the envelope with its correct address? So first of all, I'm going to ask you, how many slots are there? Of course, there are 4 slots. So 1, 2, 3, 4. Let's fill up these slots. So you want one of them to be wrong. So you want 1 W, and you want 3 to be incorrect. So 1 is incorrect. The second one is also incorrect. The third one is also incorrect. So this is the slots that you get. Let's try filling up the probabilities here. So what's the probability of sending? It's the other way around. So you got to have one as correct and the other as incorrect. So I'm just going to rewrite this. because only one has to be at its correct address. So I'm going to say one is correct, the other are wrong. So CWWW, right? So the first one, so not the first one, like one has to be the correct and the other has to be incorrect. So what's the probability of sending a letter to its correct address? That's just one way of doing that, because there's no other probability of that happening. Now, what's the probability of sending a wrong letter, right? Now you're left with how many letters? You're left with 3 letters, right? So so you cannot send that letter to its address, because that will make it correct. So you can only send it to 2 addresses out of 3 addresses. Now let's move on to the next one. Now for the next one, you have to send this to an incorrect address, and you're only left with 2 addresses, so which means there's only one option for you. And for the next one, there's just one way of sending it to the wrong address, because you got only one address left, which is incorrect. Let me reiterate that. What's the probability of sending one letter to its correct address? That's just 1, because you can only send it to the correct address. And what is the problem? Now you're left with 3 letters, right? So let's just ignore this completely, right? So you're left with 3 letters here. 3 letters, which means that you have to send it to the wrong address, which means you can only send it to 2 addresses. Then you got another 2 letters, which means you can only send that to 1 address, and then there's 1. Now comes the question of arrangement, and this is what makes this question tricky. This is not really www. This actually is w1, w2, w3. So there's basically an order to it, which means there is only one way that this can be arranged. You cannot switch the letters, because if you switch the letters, there is an interdependence among the letters that it may be sent to the right one. So there is only one arrangement to it. So if there's only one arrangement to it, that means there's no arrangement. The order matters here. So if you figure out the probabilities, so the answer comes out to be 1 by 3. So here's the answer. And I want you to do one thing. I want you to go online, go to GMAT Club, and try to see the solutions for this question. It's quite long solutions that you get. But using the slot method, it's very, very easy. But the trick here is to figure out that you cannot exchange the letter addresses. So the order matters here, right? So you cannot create other arrangements for this particular W1, W2, W3. There is only one particular arrangement for it, because even if you switch one letter, you're going to send it to the correct address. So there is no other way you can arrange it. And then you just multiply the probabilities and you actually get the answer. So that was good. I hope this video was helpful. And if you're interested in our GMAT courses, you can go to our website, and I am constantly adding content to the platform. I'm active on the platform, and I will also be adding a new course related to the new GMAT. So if you are preparing, if you want to prepare for the new GMAT, which is going to be rolled in late 2023, I'm preparing the course for that, and the course is available to be viewed, and please subscribe to the channel and keep watching for more content. And thank you very much, and I'll see you in the next one.